A very good day to my supervisor, Dr. Mazia Binti Muhammad, and a panel of judges. My name is Lee Sin Jie, and the title of my thesis is Color Detection using Computer Vision Technique. This is an overview of my outline. We will start by introduction, literature review, CNN color detection, CNN color detection, result, conclusion, and last is a recommendation of future works. Introduction. As we know, color is one of the important elements of an image that helps to describe the object. Detecting color is an easy task for humans, but it's not for the computer. If a color in an image or video can be detected, it can be used in various scientific applications and industry. Color detection is a system where computer process input data and detect a particular color in an image. A color model can represent a chosen color using a set of primary colors mapped to the color model. It describes the value and it can be read by the computer to distinguish the color of an image. Problem statement. For people who are healthy and normal, color can determine easily, but for blind people, they will not be able to determine the color by themselves. They are unable to distinguish an object in terms of color, appearance, and shade by using visual inspection, and these are the challenges facing by them. In addition, people with vision impairment will limit them to perform daily activities and affect their ability to interact with the surrounding world. To improve their life quality, color detection is one of the important elements to increase the ability to recognize a color. The objective of this project is to develop a color detection algorithm. The scope of study: first, to develop a color detection algorithm using deep learning method. Second, to analyze the performance of color detection algorithms. Third, to do the comparison study in between the algorithms. This is my research methodology, which we distribute into two parts, UGP1 and the UGP2. For UGP1, I'm doing a background study and a literature review, study the color extraction method, algorithm development. For UGP2, I'm doing the testing algorithm, analysis of performance, study the comparison between the algorithm, and the thesis writing. This is the Gantt chart for my UGP2. I'm spent 14 weeks to complete the task. Literature review. The title is Analogizing Time Complexity of KNN and CNN in Recognizing Handwritten Digits. From the results, the accuracy of 10 in KNN is 96.2%, while CNN is 98.1%. From the findings, I found that the advantages of KNN is simple, no training time required. The disadvantage of KNN is memory requirements. The classification time is low. The advantages of CNN is highest classification accuracy, the lowest class time as compared to KNN. And the last is disadvantage of CNN, high computational costs. The title is Vehicle Color Recognition using Convolutional Neural Network, CNN. So from the result, the RGB color space achieved the highest accuracy of the testing process with average accuracy of 94.47%. From the finding, I found that the conversion matrix show the most worst accuracy is green and gray color class with above 10% of misclassification error. Methodology. The figure 2 shows the flowchart of color detection algorithm, KNN and CNN. Based on the figure 2, the color detection algorithm was distributed into two parts, which are training and testing process. Training process involves a training of database in order to produce a model and data file for testing part. The training database contains 1,400 images, while testing part contains 350 images with 7 classes of color, which are black, blue, green, orange, red, white, and yellow. After the training process was done, the testing process was conducted by predict the input image one by one or through the algorithm. The result are computed in convolution matrix, and the performance of algorithm was analyzed in 4 parameters, which are precision, recall, specificity, and accuracy. K nearest neighbor, KNN. KNN algorithm is a supervised machine technique which keeps all the trained data for classification and regression. The general workflow of machine learning is given at below. Figure 3 shows the KNN machine learning method flowchart, which is start by image preparation, picture extraction, and last is a color prediction. While the figure 4 shows a flowchart of KNN classification algorithm, which is start by compute the Euclidean distance, define the value of K, work for the label, and last is the color prediction. For the color extraction method, The color histogram is a method used to extract the feature of image in KNN. In training process, it performs feature extraction for getting the RGB color histogram value of training image. In order to create a feature vector for training, the RGB values was obtained through the bin number of histogram. For example, the dominant RGB values of a red color, which is given at the below, is 254, 30, and 24, which is represent for RGB values respectively. After getting the RGB values for each training image, then the value was labeled with color respectively, and this feature was deployed vector in the file, and this is the way how KNN training the image. Classification process. Training process of algorithm only consists of storing features vector and the label of training data. In the classification process, the unlabeled point is simply assigned to the label of its k nearest neighbor. Based on the figure below, suppose S is a point for which labels needs to be predicted. First, find the k closest point to X and then classify point by majority word of its k neighbors. Each object words for their class, and the class with the most words is taken as a prediction. For finding closest similar points, find the distance between a point using distance measures such as Euclidean distance. Convolutional neural network, CNN. A CNN is a deep learning algorithm which can take an input image, assign importance to various aspects or objects in the image, and be able to differentiate one from the other. Figure X shows the entire process of CNN algorithm approach, which is distributed into two parts, trend set and test set. Basically, the image obtained from different sources were of different dimension and size. Therefore, all images need to be resized to one standard dimension. Based on the training set, the color feature was extracted through the architecture of CNN, and the model was saved in H5 format. The process of test set is similar with trend set, but the test set will validate the training model, and the result was computed in confusion matrix. The architecture of the network is summarized in Figure 9. According to figure, CNN architecture consists of 2 base networks and 8 layers for each base network with total 16 layers. The first 2 layers of CNN architecture is a convolutional layers, and it does convolutional process following by normalization and pooling. The third and fourth layers does only convolutional process. The fifth layer does convolutional layers with pooling process, and the remaining 3 layers are fully connected. Convolution layer. A convolution layer is a layer that do a convolution process, and it is the first layer to extract the features from an input image. According to the figure 10, a convolution is a linear operation that involves the multiplication of a set of weights with an input. The multiplication is performed between a 2-dimensional array of weights and an array of input data called a kernel or filter. The output array from this operation is called a feature map. Once a feature map is created, each value in the feature map was passed through an activation function. In this CNN network, value activation was applied for all layers as non-linearity function. This is due to deep CNN works with value trained several times faster than other activation function. The main advantages of value is that it does not activate all the neurons at the same time. It means that the neurons will only be activated if the output of a linear transformation is less than 0 by refer to the graph. Based on the figure 11, when the input values is negative, the result will be 0 and the neuron will not be activated. The function of the pooling layer is to reduce the spatial dimension of the input and the computational complexity of model. Therefore, it can prevent overfitting. Before going into a fully connected layers, the pooling output of the fifth layer from 2 base network is concatenated and flattened into a long vector. Fully connected layers connect every neuron in one layer to every neuron in another layers. The function of fully connected layers is to apply the result of convolution or pooling process to classify the image into a label. After passing through the fully connected layers, the final layers use the softmax activation function for classifying the generated features of the input image into various classes based on the training dataset. This is the result of color prediction. As we can see, the prediction of color was shown at the top of the left-hand side in the image. For the misclassification example is shown in the last 2 images, which orange color are wrong predict to red color and green color are misclassified to black colors. The training model was done in a Google Cloud server, and the algorithm was being run on Tesla K80 GPU for 50 epochs. Figure 14 shows training accuracy with 0.9649 and the validation accuracy with 0.9743, while Figure 15 shows training loss with 0.1232 and validation loss with 0.0665. Based on the graph, the plot shows that the model has a good fit plot and there is no overfitting occurs. The method used for color detection algorithm in vision impairment system is one of that have been tested to investigate the effect of different intensity of color image towards the performance of algorithm. Table 1 and 2 shows a confusion matrix of a classification result using KNN and CNN respectively. Most of the color class obtain higher than 80% classification rates with both methods. Also, in both methods, a large number of orange images were misclassified as red, and this can be explained by ambiguity in intensity between orange and red classes. Besides that, white color images are not misclassified as other class, and it indicates that a lower probability of white color image labeling as other classes. The value of true positive, false negative, false positive, and true negative was calculated based on the value from confusion matrix. And this value needs to be used to determine the four parameters, which is precision, recall, specificity, and accuracy. Table 4 shows the four parameters to measure the performance of algorithm, including precision, recall, specificity, accuracy of a testing result. Based on the table, it shows that CNN is getting a higher performance in four parameters, which 92% in precision, 92.1% in recall, 98.6% in specificity, and 97.7% in accuracy. This is an analysis graph based on the table 3, which include the precision, recall, and specificity. According to the figure 16, it shows that the white color class achieved the highest precision of 100%, while orange color class showed the lowest precision with 68% in KNN. For recall, red color class shows the lowest recall value with 71.7%, especially in KNN algorithm, due to their 24 images of color classes are misclassified in red color. This result indicates that the different intensity of color training database and test image contribute to misclassify in the recognition process. Besides that, specificity is one of a parameter to evaluate the true negative rate of a database. Based on the figure 18, the CNN outperformed with average specificity of 98.7%, while the average specificity of KNN is 97.9%. As concluded, this situation is indicate that the misclassified cases among a 7 color class is low. Figure 19 shows the accuracy of color class in CNN and KNN, while Figure 20 shows average accuracy of both algorithms. Average accuracy is represented to the overall accuracy of KNN and CNN algorithm, which is a fraction of a total sample that were correctly classified by the classifier. From the overview, it clearly shows that 97.7% average accuracy of CNN is the best performance algorithm if compared with 96.4% of KNN. The variation of the accuracy among the algorithm is not much difference, so it means that the performance of both algorithms is high. In conclusion, the variation of accuracy is more, whereas CNN machine learning method achieved 97.7% of average accuracy, while KNN achieved 96.4% of average accuracy. Thus, the objective of this project has been achieved, which is to study the performance of different algorithms used in color detection. Although the results of KNN is not accurate as CNN, however, it still can be improved by increased various environment of training image. For the recommendation of future works, first, for comparison and evaluation, other machine learning methods should be met. Second, more random and various intensity of image in database is required to develop a high performance of vision impairment system. Third, the color detector application should be developed in mobile application. Thank you.